Okay. Okay. CB Sanathan. Okay. Dr. Najar. Oh, he's gone somewhere. We have to invite somebody for this next month's lecture series. Welcome, Sangita.
Hello, sir. Good afternoon.
Good afternoon. Good presentation. Thank you very much for
Thank you.
for contributing this presentation.
My
Uh, we have another presentation before the conference.
mm-hmm.
This will be in the month of August. And
Okay.
do you have any colleague, any senior, any person, or any good experts you know? It's maybe any area, aluminium, but it should be in aluminium industry.
Okay. I will let you know, sir.
Please let us know, because this
Right?
is the last in this series, and then I hope I will see you in this conference. What is your plan?
No, no plans as of now. Let me think
Okay,
over it. Yeah.
okay,
I'll get
please.
back to you.
We met your CEO. Oh, Dr. Najar is here. Dr. Najar.
Sir, good evening,
Ye-
sir.
yeah, from JNRDDC. Can you make
Yes,
any
yes.
good presentation in the August lecture series? Please think and contact me after
Uh,
this conference.
yeah, sir. I have to check with the schedule actually. I'll
So,
revert you.
check
Yeah,
everything and let me know after this presentation. Maybe we'll discuss. So
yeah,
this
sure.
is interesting presentation today on bauxite residue by
Yes, yes.
Sangita Sadafule. She is from Vedanta Alumina from
Right,
Lanjigarh.
right.
Sangita,
Yes, sir. From
are you
Lanjigarh.
from Lanjigarh? Other day we met your CEO Rajiv Kumar. Rajiv
Mm-hmm.
Kumar, and he has agreed to be the one of the guest of honor in IBAAS conference.
Good.
So we hope there will be a big team of delegates from Vedanta.
Yeah, sure, sir.
Okay,
People will.
okay. So another 9 minutes to go. So we will see. I hope there will be 30-40% minimum they will join for this presentation. And after the presentation, there will be online questions answers. So that's what. Dr.
Okay.
Muhammad Nazar is also working on JNARDDC. You know him. He is also working on Red Mud.
Yeah,
We
I
have
had a
met.
talk. Yeah, we had a VC last month. I think few months back. I had a talk with Sangita ma'am. So regarding red mud utilization and all.
Okay.
We have been
Okay.
working with JNRDC
Yes.
over few projects, so we are
Yes.
in
Oh,
touch.
okay. Okay. So let us see. Our friend Mayur has joined. Acha, okay. Gautam Chatterjee is also there. Okay. So good number of people will be there, hopefully. Okay. Vishwajit Tripathi, from where Vishwajit Tripathi is from. Is he from Vedanta?
Ajit Tripathi.
No, I don't
No,
know.
it's not from here at least.
Okay. Okay. So Mohammad Nazar, you have two places you are on. I,
One is my office PC, I think. So I will switch off from that one. Yeah.
okay. Very good. Okay, 6 others are there. Anybody interested to visit Angul smelter? We are organizing it post-conference visit. So we are spreading that one. And today, yeah, we got permission from CMD Nalco. So we'll wait for another 6 minutes and we'll start the
Okay, sir.
presentation, recorded presentation. Mayur, talk to me after this presentation. Okay.
Good morning, sir. Yes, I will.
Yeah, please.
Yeah, we discuss. Yeah. Okay.
Hello, George. How are you? Your sound is not there. Anyway, we'll discuss.
Can you hear me?
Yes, yes, I can hear you, George. Keep good health, and we will see you in IBAAS conference in Bhubaneswar.
Thank you. And I am sending you some things not later than Sunday.
Okay, no problem. We will wait for your paper.
Thank you. Thank you.
Thanks. So already 18 people have joined. Let us see. It should go up to 30, 35. Hello, Shankar.
Hi, Ashok.
Hello.
Hello, Georgie.
Hello. Good afternoon.
Good afternoon. Hi.
I'm looking forward to seeing you at the IBAAS conference.
Yeah, sure.
Okay, 21 persons have joined. So let us wait another 2-3 minutes and we will start. "25, 28, E.K. Kakkar. He joined. Okay. Oh, almost 30 persons have joined. Khalil Khaji have joined. Very good. Khalil, hello, ladies and gentlemen. So today we have with us Sangita Sadafule. She is in Vedanta at in their refinery, and she is going to talk on bauxite residue. Maybe 2 minutes. Sangita, you introduce yourself, and then your presentation may start. Okay, Sangita, please.
Hello, good afternoon, everyone. This is Sangita Sadafule. Currently, I'm working with Vedanta on red mud valorization. Yeah, it's been almost a year now, closer to a year that I have been working with on this profile. I have been working with different industries. I've been working with different industries, trying to different sectors, automobile, steel industry, vanadium extraction, and I have over 3 decades of. It's can you hear me?
Yes, yes, yes.
Yeah,
Yeah. So over 3 decades of experience in operations and manufacturing. Thank you.
Thanks, Sangita. We will start with the recorded presentation of Sangita, and then afterwards she will be available to answer your all the queries on her presentation. So I will request Priyanka of IBAAS office to start her presentation and mute everybody. Thanks, Sangita. Priyanka, please.
Good day, everyone. Welcome to the session of Red Mud, the Untapped Potential. I'm Sangita. I'm responsible for red mud valorization at Vedanta. In the past, I have been enabling organizations to ensure sustainable, profitable growth by strategically leading greenfield, brownfield, and capacity enhancement projects, ensuring ESG compliance, fostering innovations, and building long-term trust of stakeholders. I'm delighted here to share insights on the topic that are close to the core of sustainable refining, alumina refinery. The lecture explores the origin of red mud, the chemical nature, the challenges associated with the handling, and the most important, transforming this industrial byproduct into a valuable resource. Let's know more about red mud. Red mud is also known as bauxite residue. It's a byproduct of IBAAS process. Red mud is red in color. This color is from the iron oxides present in it. Red mud also has other oxides like aluminum oxide, silica, titanium oxide, and calcium oxide. In IBAAS process, bauxite is treated with caustic soda to extract alumina from it. What remains is known as red mud. Red mud contains rare earth elements also. Now that we have seen how red mud is generated in the IBAAS process, here we are going to just understand the amount of red mud that is generated. For every 1 ton of alumina that is produced, almost 1.5 to 2 tons of red mud is generated. Here in this graph, in this chart, we are seeing the red mud generation as on 2023. Here we can see that the red mud generation is going up year on year. Current scenario, if we say in India, we have three major refineries, Hindalco, Nalco, and Vedanta. Collectively, they are producing around 9 to 12 million tons of red mud annually. This red mud generation, we see that it has a range of 1.5 to 2 tons. This generation
Not able to hear.
the audio is paused, I suppose.
Priyanka? Sorry.
The untapped potential. Insights on the topic that red mud also has other oxides like now that we have seen how red mud is generated in the IBAAS process, here we are going to just understand the amount of red mud that is generated. For every 1 ton of alumina that is produced, almost 1.5 to 2 tons of red mud is generated. Here in this graph, in this chart, we are seeing the red mud generation as on 2023. Here we can see that the red mud generation is going up year on year. Current scenario, if we say in India, we have three major refineries, Hindalco, Nalco, and Vedanta. Collectively, they are producing around 9 to 12 million tons of red mud annually. This red mud generation, we see that it has a range of 1.5 to 2 tons. This generation depends on the bauxite quality, the refinery efficiencies. On this slide, we are going to look at the IBAAS process. What is IBAAS process and at which stage of the IBAAS process red mud generation happens. Once we have received the bauxite, it is sent for crushing and ball mill. The basic reason to do this is to increase the surface area, which will help in better chemical reaction. The next stage is desilication. Here, the reactive silica is removed so that they don't form unwanted products that will reduce the efficiency in the next process. Digestion is the critical process in the this IBAAS process. Here, the alumina in the bauxite is dissolved in the caustic and it is sent to the settler. If the digestion is proper, then the recovery of alumina will be better off. That is the reason this is a critical process. For this process, we are using high pressure steam and caustic as the process to dissolve the alumina from the bauxite. After the digestion process, the output is sent to a settler. Here, the filtrate and the sedimentation happens. The filtrate is containing the alumina, which is sent to the filtration, and what remains is the bauxite residue, or we call it as the red mud. It is sent to the washers and then to the red mud pond. Here, very critical thing is the separating out and proper washing. The red mud is in the form of liquid. We in Vedanta were the first to go in for filter press technology. What is filter press technology? This liquor is taken, this liquid red mud is taken to the filter press where the residual liquor is removed and the red mud is formed in form of cakes where only the solid part remains and the liquor is sent back to the process. By doing this, we are reducing the water consumption, improving the water positivity. The second is getting back the caustic to the process, reducing the caustic consumption, and the most important, since it is in the cake form with a moisture of 20 to 25%, it is easy for handling and stacking. If it was in the liquid form, then the amount of space required to handle this would be huge. So Vedanta took this step of putting in filter press first in India. Then after the washers, the filtrate is going to the filtration. After that, the precipitation happens and then calcination to form alumina. Here is the SWOT of red mud: strength, weaknesses, opportunities, and threat. In the strength, I would like to mention the high mineral content. The second part is easy availability, abundant availability, potential to reuse, and environmental awareness. On the weaknesses, in the IBAAS process, caustic is added, so the red mud has high alkalinity. The second, as we discussed in the previous slide, storage challenges. So if we don't have filter press in the liquid form, storing red mud is a challenge. The third, I would say the commercial applications. Still, the commercial applications have not been explored to the extent they can be. The transportation cost. All the refineries, if you see, are closer to the mines. The mines are away from the prime places. So transportation of red mud becomes a challenge. In opportunities, encashing the strengths, metal recovery techniques could be explored, green construction material, policy support from the governments, collaborations with the technical institutes can be the opportunities to work on. Threats, the environmental regulations, public perception, because of the alkalinity, this red mud is considered as high volume, low toxicity material. Market volatility, we have minerals in this, but depending on the market situation, the cost of the minerals can vary. Natural disasters, storing red mud is a challenge because of its alkalinity, and if there are any natural disasters like heavy rains or earthquakes, there could be breach of the red mud storage ponds, which can be a threat, a major threat, I would say. One way to harness the strengths of red mud is metal extraction. For this, Vedanta is working with different technology partners to extract metal. Red mud is a complex material in which metals are found in different forms. Understanding how to extract it is the key to this process. Here we can see that there are different technologies available in the market, but they are in the primitive stage. Vedanta, along with these technology partners, is looking at how to extract metals from red mud. The first platform that we are working is with our technology partner AIT. AIT has already put a pilot plant in alumina degrease, and we are also trying to see how this technology can be used for the Vedanta red mud. In this technology, the clean tech furnace is used, and by this process, we can extract pig iron and mineral wool, which can be used. Pig iron can be used for the steel industry, and mineral wool can be used for insulation purposes. We are in the process of evaluating this technology and working with AIT to see how we can take this technology forward. The second is Phoenix Tailing, a US-based company. We have signed an agreement with them to see how we can extract metals from this. The basic focus in this would be Fe2O3 and pigments. We already know that there's a red color to it. So how we can utilize this red pigment for different industrial applications. The industries that could be color industry or printing industry. So this is what will be done in this project. The third one is Proman Dynatech, our technology partner. We are working on plasma arc furnace, using plasma arc furnace to create alloy steel. Since it's a plasma arc furnace, the cleanliness of the steel, or we can form clean steel and also do alloying. So in the other methodologies, it was iron or pig iron that we were targeting. But since the methodology or the technology used has changed, here we could get a better grade of steel, alloy steel. A pilot plant already is in the commissioning of the pilot plant is in progress, and soon we will have the commercial trials done, and we will be able to make alloy steel. Here we can see that there are so many technologies. The major concern or the major challenge, I would say, is the techno-economics. You can extract minerals from it, but then it should be techno commercially feasible. Technically, you can say that, okay, we can have all these elements, but at what cost is also the critical parameter that has to be looked in. And this can be done only when we have done some commercial trials and come to some conclusion saying what is the input to output ratio. MTM is one more technology partner. Now here again, the technology of extraction is changing. Flash Joule technology is being used to extract iron and other elements from red mud. The last one, but a different thought process, I would say. IIT Kharagpur, Dr. Channa has a patent set where it is removing iron from bauxite. By doing this, we are working on the reduction of generation of red mud. So here, till now we were talking about extraction from red mud, but we are going to the base. We are going to stop or reduce, not stop exactly, but reduce the generation of red mud. By doing this, it will not only reduce the red mud generation, but also will increase the efficiencies of alumina recovery. So here, this is more of a hydro and hydrometallurgical process and pyrometallurgical processes that will be implemented to remove Fe2O3 from bauxite. This is one more platform, a collaborative platform, I would say, where all the alumina refineries have come together under the umbrella of Niti Aayog, and the technology partners are NML, JNRDC, IMMT. We have brought the synergies of industry and knowledge technology partners to design a process to extract iron, alumina, titanium, and rare earth elements. Recently, in June, the final report has been published, and now industry are working on it, on how to take it to the next stage, the pilot stage, where the processes can be commercialized to extract iron, get alumina back to the stream, so that the waste, the recovery that had not happened in the IBAAS process can be brought back to the IBAAS process, enhancing the efficiency, improving the recovery of alumina, and the others are titanium oxide and rare earth elements. The rare earth elements will be in the rare earth oxide forms. Here I would like to discuss the topic of limited commercial application, how we can convert the weakness into strength. The objective here is basically to enhance the commercial application of red mud. The strategic approach I feel is that government mandate of using red mud in the following application. Cement industry is a proven technology where cement industries have been using and are using red mud in their clinkers. The second is the road application. The road construction, in road construction, red mud can be used in the sub layers and embankment. This is been proven by researches done by CRRI, CBRI, and it's very clear that it can be used. If there are government regulations, we can make this happen by implementing a mandate. We all know that India is a developing country and the infrastructure landscape is changing very rapidly. We have huge number of national highways coming up. So if this can be utilized, it is a major avenue for bulk utilization of red mud. The benefits is like, if it is made a mandate, then as we all say that necessity is the key to find innovations. This will happen here also. If there's a mandate, then people will start thinking about how to utilize it. This is an example. There's an example where fly ash also is being made a mandate, and people have started utilizing fly ash in different avenues. Similarly, we have to think beyond our limits and see how these mandates can help for usage of red mud. The second part is, if there are some incentives that are proposed by the government, that will also be a motivation for people to utilize red mud. As touched upon in the previous slides, we know that refineries are remote places, and reaching the cement factories, for example, is a major challenge, and the cost incurred in transporting this material is huge. That also limits the use. So if there are incentives on transportation, then this will help people to think on the use of red mud. It also promote, by doing all this, we are also promoting circular economy and reducing the industrial waste. We see day by day the space is becoming a constraint, and if the speed at which new refineries are coming up, like Vedanta is moving to 5 mtpa, and then next stage will be 6 mtpa, the red mud generation also will be that much. So we have to have such schemes in place to ensure the effective utilization of red mud. We have considered red mud as a high alkaline material. Now, in this slide, I would like to bring to your notice how we are converting the weakness of red mud into the strength. FGD, flue gas desulfurization solution. Here, normal in the industry, lime FGDs are available. Here we are going to use red mud as a absorbent to absorb the sulfur in the flue gases. The reason is alkaline nature of red mud is going to enhance the sulfur trapping in the flue gases and improve your carbon footprint. We all know that the regulations from the CPCB on the carbon emissions have been becoming stringent and stringent day by day. ADCAT Technologies has come up with a solution where red mud can be used instead of limestone. The benefits of using red mud in the FGD is utilization of waste. This FGD can be in two forms, solid as well as liquid. The ones who don't have filter press and don't have solid red mud also can utilize this type of FGD. It is one of a kind of a solution where we can have circular economy. Every industry now is moving towards zero emission, how to achieve the goal of zero emission. So this will be a support to that goal of every industry. The benefits, what comes to our mind is the benefits. How is it better than the existing limestone FGD? When limestone comes into picture, we have to procure limestone. Limestone is a natural resource. We know that the natural resources will deplete sooner or later, and the quality of the limestone has to be good so that we ensure 100% absorption of sulfur. The second, the byproduct formed from after the use of limestone in the FGD is the gypsum. Handling of this gypsum is also a challenge in the limestone FGD. If we go with the red mud FGD, the product that is coming out after the absorption, the red mud that is there, we can use it as a natural soil for any application. It becomes a neutral soil. So if you look at it, this is a positive thing. Now it is time that we look into such innovative ideas and bring them into implementation and see how we as industry support circular economy. ADCAT is working indigently on this project, and we at Vedanta are collaborating with ADCAT to see how we can have a FGD operational with red mud. Or already in some countries, European countries, they have tried it out and it is successful. Another weakness that we touched upon is the storage challenges. Since red mud is produced in bulk, in huge quantities, storing is a challenge. The second, it's alkaline and the leaching is possible. So storing is a major challenge, but we could convert this challenge into an opportunity by, by converting these huge red mud dumps into green zones, afforestation. Yeah, this I would call it as the red to green revolution, because every industry, every alumina refinery is having millions of tons of red mud, legacy red mud that is lying in with them. So utilization of this is a challenge because many of the technologies are in the primitive phase and it will take some time. And simultaneously, the addition of red mud to this red mud locations is increasing. It's not stopping because every refinery is expanding, producing more alumina and in turn generating more red mud. So the solution for this, there's a solution to this problem also, converting them into green zones. Already our refineries are working on this. Some have already implemented. Vedanta is in the process of implementation. So this is other thing where we can bring in green zones, build biodiversity, and help the community around by giving them a greener future. Red mud provides strategic opportunities for value creations. We have discussed metal recovery technologies. These all are in the primary stage. To make it profitable also, we have to focus on the rare earth elements extraction. We all know that the rare earth element availability is scarce. So we have to focus on how we can extract. The reason for not finding a easy way out to extract the rare earth elements from red mud is because of the high chunk of iron in it. So unless and until we focus on the extraction of the iron, the second is the alumina, silica, titanium, then we can go to the extraction of rare earth elements. So we as industry and academia have to come together and build in synergies and see how the knowledge is converted into practical solutions. We have seen, if we go and search for literature on red mud, there's a lot of literature available on red mud. But if we go and check out what are the applications or real use of red mud, it is very less. So converting the knowledge into practical solutions is key to encash these opportunities. The second one is the green construction application. Red mud has iron, silica in it, which makes it suitable for bricks, not just the normal bricks, also the refractory bricks, which can withstand the high temperatures. The second is the tiles. The tiles, not the normal tiles, just but X-ray shielding tiles. So it has the capability to shield the X-rays. When we go to any X-ray machine center, or even if we are working in labs and see when there is a X-ray machine equipment, there's a lot of care and barriers that we have to build so that those x-rays do not affect the human body. But if a simple tile can do this, that's the easiest way out. So here I would like to say that there is a lot of knowledge base, but converting it into practical solutions is becoming a challenge, I would say, because of the techno economics. Initially, to start off with, at least I feel that the techno economics has to be kept aside, and we really have to focus on how we could first streamline the process and look at the productivity and return on investments at the second stage. But because of seeing that at the primary stage, we are not able to move ahead and do the bottlenecking of the hurdles coming in our way. The second thing, this can be overcome, I would feel, by policy supports and incentives. If there is a focused approach and the government is also supporting for the industrial waste recycling and some circular economy initiatives are put in place, I think there could be a great support to the industry as well as the academia to support such type of studies. Here let's talk about the threats that red mud poses to us in the industry. Environmental regulations is the first thing. Right now, there are environment regulations, but they are not that strict. If these start getting stricter, then the compliance cost for storage and disposal for the industries would become a major cost. So this could be a major threat in the coming future. We see that the compliance norms are getting stricter and stricter year on year. If you see the SNOx and NOx values, they are becoming tighter and tighter on the contents in the flue gases. So similarly, if such type of restrictions come onto red mud, it would pose challenge to the industry. The second thing is the public perception. Because of its alkalinity, people perceive it as hazardous. If you look at it in small amounts, it's not that hazardous, but because of the perceptions, it is posing a challenge to the industry. The other part is the market volatility. We are now have discussed at length on metal recoveries. So we are talking about iron recovery, alumina recovery, and when we are doing the recovery calculations, the plant setup, capex, opex, then we always consider a certain value for return on investment calculations, the certain sales price. But in a volatile market, the prices are going up and down. So it would be very difficult to foresee what exactly would be the profits that could be earned by the metal recovery. So this is one challenge that is there and that needs to be handled. The last one, which is critical, not in our control, I would say, is the natural, nature disaster, the natural disasters. So here in the floods, taking care of the red mud ponds, the red mud disposal areas is a challenge, and also the earthquakes. So for these natural calamities, if there are any, it could create a havoc for the industries. So these are the threats, pitfalls, whatever we call it, for red mud. Even after so much time we have discussed, if I ask the question, what is red mud? The first thing that will come to mind, it's a waste, it's a challenge, it's a difficult thing to handle, it's a pain. Yeah. So here this is about a perception, a mindset. Now, if we have to change it, we have to change our way of imagining red mud. We have to imagine red mud as a resource and not as a challenge or as a headache. Yeah. If you look at red mud is a complex, is a material with a complex chemistry. If we can properly understand it, then we can find a solution to handle it. It's like we say, the problem well defined is the problem, half of the problem is 50% problem solved. Similarly, I would say red mud is also is on the similar line, and it's a complex, it has some complex chemistry which we need to understand to find a solution to the commercial application. we have to lead the way for innovations. Like Vedanta has been exploring, collaborating with with different technology partners, similarly other industries, or coming together, developing the synergies to sort this red mud valorization is the key to handle red mud. Sustainability, reimagining sustainability together, like I mentioned, synergies. Yeah, everyone, if we take as a goal of 100% utilization of red mud, not building new storage areas, maybe okay. At a certain stage, we can define utilization, how much of the generation are we utilizing, and not immediately taking the legacy stock into our calculations. That also would be a initial big step towards the mindset change, and also looking at the different sectors in which red mud can be utilized. Like we say, road application. Road, we in industries also are making internal roads. So it is, if we start it from ourselves, it becomes easy to convince others. Yeah, it's like we say, lead by example. So if we can utilize it in our internal roads, then it becomes an example for further application. This is the other way of bringing in cross-sector commercialization and thinking about all synergies coming together and chalking out a circular economy model can be the future and support for 100% utilization of red mud. This is a collective effort that can be put in to ensure that 100% utilization of red mud happens, and the the metals that are in it can be utilized for other applications. Thank you.
Thanks, Sangita. That's what the interesting presentation. Just a small note, Sangita, we cannot tell everything red mud. We call it as bauxite residue because in many countries, bauxite is not red. It is of a different color. So it's not always red color residue. It's better to use terminology bauxite residue. Just a small comment, just for because we had come across many places discussions on this subject. So now it's open for discussion, and I will request Sangita to be ready to answer some of the queries. You are welcome to ask question. George, you are the first person to ask question. Please go ahead.
Well, I hope you can hear me.
Yes, we can hear you.
So I can add something. The remark of Ashok. Several years ago, I noticed that there are researchers and process suppliers and so on who are confused whether let me the red mud is the solid material, or is it a slurry, or with the cake or whatever. So for the sake of clarity, I do recommend, as Ashok said, use bauxite residue. Nevertheless, there are places in Europe where they figured out processed bauxite or something like that. Also for the bauxite residue, I am a little bit more conservative, and I prefer the bauxite residue, which I think it is a clear term. Thank you and congratulations to your presentation.
Thank you. Next time we'll ensure that we use a standard terminology, bauxite residue.
Thanks. So let us have a more question. Thanks, George, for giving your view. And let us have some more question because that's very interesting presentations. He has shown all the cooperation they are making with different technology suppliers. And you remember our friends in Greece, they are also working with them. So it will be interesting thing to see how it gets developed. So anyway, please, Shankar or anybody. Shankar is from Belgaum. He worked for a long time in R&D. So Shankar, if you have any question, because you compiled many papers on red mud. Anybody else questions?
Annapurna has raised
Annapurna, yeah, please, Annapurna, please.
Hello, ma'am. I'm Dr. Emia. Annapurna is sitting here. We have a research in our lab going on the recovery of rare earth elements from. It was an SCRB funded project. So I would like to know whether the NITI Aayog report public or how can we get that? While I was in my postdoc, developed a process. Andium actually. So when I came, I know Dr. Chen, we have worked in the same project. So we have started working on rare earth elements all together recovery. So once some suggestions came to me saying that the NITI Aayog report, but I see the report in the full form. Can we have a look at it? Or is it just to the public?
Ma'am, to answer you, it's not to the public because three industries, Hindalco, Nalco, and Vedanta had come together and worked on the project under the umbrella of NITI Aayog. So it was in a limited edition. The project report has been distributed in limited edition. So maybe we'll have to check on how we can whether it will be available in public domain or not, because it is specifically people have come together to work on it. So it's I would say it's in private domain, not in public domain as of now.
Okay, thank you.
Welcome.
Yeah, Saurabh Sanyal, Sarvendu Sanyal, please go ahead.
Yeah, thanks, Ashok, and a nice presentation, Sangita. This is Dr. Sarvendu Sanyal. I am from Jamipol Limited. Jamipol Limited is a Tata Steel Group company and supplying different solutions to steel companies like desulfurization, dephosphorylation. You may remember that we recently contacted you through Dr. Amit Chatterjee to use some of your byproducts, so to say, for value-added products in steel industry. My question is related to red mud again. The red mud, we had gone through the composition shared by you or your team. Is there any process which could increase the Fe2O3 percentage in the red mud? Because we are looking for using it in one of our additives where Fe2O3 content requirement is little bit more than what right now having in the red mud. It is around 60% if I remember correctly.
So it is around 45 to 50%, I would say. It will bit vary depending on the bauxite input, and making the content of Fe2O3 higher in the red mud is, I would say, it is not possible, because whatever it is bauxite properties are there that are continued further. In India, only the East Coast bauxite has a different chemistry, whereas the other side of the bauxite has a different chemistry. If you look at some bauxite residue has Fe lower than 40% also, but ours is at least in 40 to 50. Vedanta residual bauxite has higher compared to the other region bauxite, because of the bauxite that we are utilizing. So it's a challenge, I think, that increasing the Fe2O3 in bauxite residue.
There may be a simple thing, Sarvendu, we in JNRDDC and other places, they carried
Beneficiation,
out
that's what you mean.
a high intensity wet magnetic separation. If you use it because it's already fine, you can increase up to 70 to 80%. And if you are interested, please write to us. We will connect you to some concerned persons in industries and in R&D center.
That will be great. So we are in touch with Sangita already.
Okay.
And we'll discuss this for the next stage maybe.
Okay.
We directly from the refinery, what comes out, that we cannot control. But whatever other projects that we are working, like Dr. Nandi said, that is possible, but there has to be processing done on it, not directly from.
Not directly, correct.
Yeah.
Correct.
That sounds good. Yeah, thank you. Thank you very much.
Thank you.
A nice presentation again.
Shankar, please
Hi.
go ahead.
Yeah, good presentation, Sangita. And this is Shankar, ex-Indaco. I'm based at Belgaum. So my one query was about the plasma process. Just at what stage is that project currently? Because we had long back, we had worked with a Russian company on a similar project. So I just wanted to know at what stage is this?
Pilot plant is under commissioning, sir.
Okay.
So once the pilot plant is ready, then only we can, all theory is there. Now practically what outcome comes, that also, we are also very curious to know.
Okay.
So it's in the commercial stage.
So if not confidential, this pilot plant is coming up where? In India or in abroad?
No, in India.
Okay. Vedanta is trying to set up this pilot plant. Okay.
Good.
Okay. Any other question? Hello? Any other questions? Yeah, Jagdamba Nanda Das. Okay, please go ahead.
Good afternoon to all, and thank you very much. It's quite an interesting presentation, and probably as discussed that instead of red mud, we call it as a bauxite residue, but whatever it may be. But my concern is, first thing, it is a highly alkaline material which are kept far off from the human interaction. First and foremost, when you handle this kind of material, so it must be in the laboratory scale or whatever scale you do, but then it is at present appears to be hazardous, high alkaline drugs. This is first one. Second one is, what is there any study at the very, very nano level? These materials, what we get here is very fine grained, and I understand that there are a lot of work going on to understand the behavior of this material at nano level, and what are your idea on that? Thank you.
So alkalinity is there, that is known parameter, and handling this, like when you are stacking it, you have to have the leachate and all that activities have to be done to ensure that there is no soil contamination or the environment contamination. So that is being taken care. On the other side, what you mentioned is about how taking it forward or how to handle it. There, it's like high volume and low toxicity. That is most important. Everyone is just branding it as that high alkaline and then are scared of it. Yeah, but when it comes in huge volumes, then, but there is no like a thin line or a definition how much volume after how much volume it becomes hazardous. That is also one thing. So these are the parameters, and looking at cement industry is already using it. All the industries, Hindalco, Vedanta are sending it to the cement industries. We are handling it through the rake movement, truck movement. We are handling it. So it is not that big a challenge how much it is perceived to be. That's why I talked about perceptions. And the other thing is the storage areas are huge. There's huge quantum of material that is there. So everything we cannot be able to liquidate. So the only solution that is there, that how to cap it and convert it into a green zone. So like our other team members, like other refineries, have already worked on it, and they have seen that for vegetation also. In some areas where the soil is acidic, so adding it acts as a neutralizer also. But these are all book level studies. So we would like industries to take it to the next level where practical application can be mentioned. I hope I have answered your question.
No, my second part was the application, the nano scale. Can it be considered as a nano material? And
there are some people who are already working on this, but we still have not got into the depth for the nanotechnology application. So for me, it will be difficult to answer that question.
Thank you. It's a nice presentation. Thank you.
Thank you, sir.
Any questions, you can put it to the IBAAS office. We can forward it to Sangita. And if you want any more details, please send us your questions to us. And then we will send to Sangita and also direct it to some of other experts working in this field. So any more question, please? Anybody else wants to talk? If not, thank you very much, Sangita. And we are really thankful to you. And we will look forward that 4 technologies you are working at present. And we will look forward to see that some of them comes as industrial application in Vedanta or any other company. And IBAAS will be in touch with you. And we will invite you in IBAAS conference in Bhubaneswar. You will be very useful. You can meet a lot of experts over there. And it is in October 8, 9, 10. So we request you to, or if you want, we request you to participate in this conference.
Sure,
because
sir.
it will be very useful for you to meet many, many experts, people, and also industry people. So, and
Sure.
it is done in IMMT also. So you can also organize your meeting with IMMT because they are your partner in this
Yes.
project.
Yes.
So please do come. And we invite all of you in the IBAAS conference. There will be one more lecture series in the month of August. However, September will be too close to our conference. So we will all meet then in October in Bhubaneswar. Thank you very much. Thank you, everybody, for participating. And presentation will also available in the IBAAS website. So yeah, Jadaba, any question? Please go ahead.
No. It's just to say you thank you. It's a good arrangement that you are doing this kind of lecture series. It's a kind of a nice knowledge sharing.
Thanks. You are welcome. Welcome. You are. Okay. See you, everybody. Thank you very much. Thank you. Thank you.